Hello, I hope you are doing well. I'm Reza Amini. Unfortunately, I couldn't attend in person, so I'm presenting our study virtually on behalf of my colleagues at Musée Lab at University of Quebec in Montreal. Our work is titled as Quantifying User Behaviour in Multisensory Immersive Experiences. First, we are going to talk about the background of multisensory VR experiences and our motivational research questions. Then I will describe our study design and methods we used. Then results and discussion will be provided, followed by conclusion. So immersive systems, based on one of the definitions, could use technology such as high-definition displays or virtual reality or augmented reality tools. They can also use accurate positional tracking and haptic feedback to provide immersive media experience. There's a diverse range of application for immersive media, including entertainment, education, healthcare, to name a few. However, most of these immersive experiences rely on audiovisual feedback, animations, lights, and spatial audio. Recently, with advances in wearables, there's opportunity to add flavor of other senses, for example, olfactory or tactile sense, into VR experiences, which could result in a really unique and pleasing user experience. In general, the success of new multisensory immersive applications will rely on the experience that they provide to the users, and not on the technology they use. Anyways, as you can see in the image, two individuals can use the same VR headset, play the same game in the same location, and have the same goals. The two individuals can have very different experiences with varying perceptions and also different behavior. So overall, the system that these individuals use, or the headset, the context or the virtual environment, or the game they are using, and lastly, the human themselves are important factors influencing the quality of experience and the pleasantness of this perception. So to measure this quality of experience and user behavior, majorly there is two ways. First is subjective approach, using questionnaires or interviews after experiment. They are mostly paper-based and rely on memory of user to answer a specific question after finishing the experimental condition. To avoid emergent disconnection due to taking on and off the wearables in studies with several experimental conditions, there are questionnaires that can be tailored inside the game. Second approach is objective or instrumented measures. For example, analyzing brain signals or monitoring underlying modulations in heart rate or even eye tracking. Having all this said, in our policy study, we tried to answer two questions in the context of an exploratory multisensory VR game. First question is related to the impact of different types of feedback, including olfactory and haptic feedback, on perception of realism, presence, immersion, engagement, and overall experience. Then we explored differences in user behavior across two experimental conditions, including traditional audiovisual modality versus multisensory modalities. So as I said, we designed a new exploratory VR game. As you can see in the image, it's an orange groove, and we ask users to surf the environment and interact with the oranges on the trees for 2 minutes. After interaction, an orange will burst. Users hear a poof audio cue, and then a combined haptic and olfactory feedback occurs based on experimental condition. As you can see in the image, there's sound icons and circles around orange object, which in Unity game designing software, they enable us to define audiovisual, olfactory, and haptic feedbacks through the available SDK. To provide haptic and olfactory feedback, we use vHaptics armband, as you can see on the left, and users have worn these haptic sleeves on their arms, and they provide vibrations. We also use OVR Ion 2 image on the right, which mounted under the head-mounted display and disperse scents close to nose. It's capable of dispersing 9 different scents, and we use flowers, woods, and pine as background scents and a citrus scent as a feedback. For collecting physiological data, we have used an instrumented VR headset where all the signal acquisition devices are incorporated within the headset to create a unique and portable system. As you can see in the image, letter A indicates mounted ion synthware, B indicates our headset, Oculus Quest, C indicates EOG and EEG channels to monitor eyes and frontal part of brain. D indicates an ECG channel which attached to the left collarbone to measure heart activity. And finally, E signifies central and occipital EEG channels. Finally, your participant pool consisted of 11 individuals. The video on the left illustrates the real-time monitoring panels, which shows modulation in heart and brain signals, and channel activity mapped on the head plot, and also feedback monitoring on the bottom. On the right, you can see your in-game questionnaire to record the ratings of participants after each experimental condition. Here is a summary of our approaches and extracted feature. As I said, we have collected subjective ratings as well as objective measurement. Different features extracted from biosignals. For example, from brain signal, we extracted engagement index and frontal alpha asymmetry, which actually is an index for approach or withdrawal tendency, reflecting the pleasantness of experience, or mental workload, which is directly calculated by theta power bands. Here we have the subjective results of our study. As you can see, perceived immersion, engagement, presence, realism, and overall experience increased in multisensory experimental condition, or ABSH, compared to audiovisual or AV. Moreover, t-tests showed significant differences between presence, engagement, and overall experience across these two conditions. Also, Pearson correlation in audiovisual conditions show the correlation between realism and immersion with overall experience. However, during multisensory condition, additional relationship between presence and overall experience on top of the realism immersion with overall experience was observed as well. Here also you can see results extracted from biosignals. As you can see in the table, we extracted this well-known features from three modalities that we had: brain, heart, and eye signals. Mean values across subjects were reported, and the values inside the parentheses are standard deviations. Increases were seen in all measurements during multisensory condition relative to audiovisual. Regarding frontal alpha asymmetry, positive values indicate greater approach tendency and motivation to continue the experience, whereas negative values are reflecting withdrawal tendency. These measures showed an increased trend as more modalities were added. Does it suggest that a greater desire to continue playing and increase the motivations? Moreover, increase in mental workload is related to an increase in engagement and attention levels as reflected by changes in the theta power band. Here we see other objective results. The scores indicate number of interaction with oranges. Importantly, Pearson correlation shows significant relationship between scores of multisensory condition with the immersion ratings. Moreover, a significant difference was observed across two conditions in both vertical and horizontal head tilt. However, despite our findings, which were aligned with previous reports, we acknowledge several limitations. Firstly, number of participants were limited. We also had to have a time interval between participants to make sure that the devices are clean and safety steps were taken to minimize COVID-19 risks. Due to limited sample size, we couldn't address gender or age-specific effects which could be present in multisensory experiments. Also, the game and task were driven by available sense, so in future we need to design more realistic environments, simulating, for example, daily life activities. So to conclude this presentation, we managed to characterize user behavior as well as quality of experience using both subjective and objective measures. Importantly, our subjective results showed impact of olfactory and haptic feedback and increasing presence. These findings also supported by biosignals, importantly positive values of frontal alpha asymmetry in multisensory condition, which indicated greater approach tendency. Thank you so much for your attention. Since I attended virtual, I would be really happy if you contact me with your questions or more information about our study.